GROQ. I'm just going to call it Grok,
Oh,
but
I
I know
love
it's
that one.
very
Yeah.
close to
Mhm.
GROK, which is Elon's thing. I know they GROQ is not very big fan that the name is so close to their name. But anyway,
Steal some web
they
traffic.
I know they are in building a completely new architecture with a big implication. So my little understanding of that is what Nvidia does with their architecture. It focuses on multi-threaded processes, and that's how the GPU works. The way they've said it is more serial. They go in for more speed than what the richness of the experience. I guess that's the best way, for not layman's way, I can explain it. So stating that, just like you are seeing this in the crypto world, right? Ethereum is our platform to beat, and Solana came in. The only thing they brought to home was speed. Hey, nobody's going to wait for 17 seconds to process a transaction. We do it in milliseconds.
Right.
So I can see the same thing happening. Is speed is going to be critical, because we've done demos where I ask a question and then you have to from there need to translate to a audio and then a video. All that adds lag time. To want to make it like a conversation you and I are having, the speed has to come significantly down. So it's just not the software piece of it that's getting better. The hardware manufacturers also experiment with new things to make this whole process better. Have you? What are your thoughts on it?
Oh, absolutely. So I think we went through this cycle where NVIDIA with GPU, then there's a TPU, TensorFlow processing unit, and then I think Grok is, they call it LPU. I don't necessarily know the exact expansion of that, but it's LPU. So these processing, let's say XPU, right? There's processing units, and probably Mac has its own type of processing unit, right?
Yeah.
So these specialized units are very essential and key to certain things, and you are absolutely right. What even in our last year's journey, we are playing with quantized models, which is basically you take a 32-bit floating point number and reduce it to 4-bit number, and then you lose resolution. That's how we are playing with, and we are still doing some good stuff with it, but it is not comparable to working with a 32-bit model weight, right? So the key question here is, what are we trading off? Right now, everybody's trading off the accuracy for showing something useful, right? And hopefully this space, the chip manufacturing or hardware space, brings in more competition, so we can actually play with very good quality models, right? That's why I'm excited. I played with the website. They have a Mistral and Llama, I think, demo, and they're already flying like 10x faster than my let's say I do the inference on a local machine with Nvidia RTX 3090. It's way better, like 10x, more than 10x faster, right? So I can't wait for some of these technologies to come to a consumer device, because then the magic happens, right? If you have one of these for inference specific, super fast on your local device, imagine what kind of a personal device you'll have.
Agree. With the 5G becoming the main thing and 6G in the horizon, the speed of connecting to these becomes faster. And then the speed at which information can be processed, especially if everything is in your phone, also gets better. I can't
Yeah, it's
even
going to
begin to
be
imagine. Yeah.
it's going to be very tiered. I think you're right. There is a 5G, the networking component, right? But what can you operate within the device in a disconnected manner, right? How accurate? What kind of intelligence can you store? And once that is exceeded, and you want something much more higher accuracy or more thought involved or whatever it is, more compute, offload it to a cloud device, right? So both of these are going to come into into play, right? Because currently there's almost nothing, very specialized devices in maybe some devices like Samsung Galaxy AI or iPhone might have something, but it's not commonplace yet. But hopefully innovation happens in that space, so people can run things locally if they want to. Then they give freedom to the device to go reach out for higher order knowledge.
Yeah, I was just thinking about. I know I want to move to your demo, but this is a use case that jumped to my mind. Is, let's say we are in an interview. You and I are talking right now. I have my phone in front of me, and it records what conversation question you're asking, and I'm just gonna be reading like a teleprompter. The answer is gonna tell me, because it has my background. It knows the job description. It knows, let's say it's a programming job or whatever, right? And it gives you the answer. So it doesn't matter what question you're gonna ask me. I'm gonna be an amazing interviewee going forward.
Yeah, exactly. That's also very true, right? So because if the it goes to the similar theory, right? If back in India when we studied, it's more like rote memory, right? Questions, it's not application of knowledge. So I think the true difference
Correct.
comes when you're asking questions in the application of knowledge field. It has very close ties to
Right.
education too, right? When education system is more read and recall, it fails in the
Mhm.
real world problem solving domain. But if it's more, there's a lot of work that need to be done to make it like a problem solving question, right?
Yeah,
So it's true. Because we do these kind of things for time efficiency, all kind of reasons.
agree.
All this will be put to test.